Hi, this video is going to have an introduction to waves. Waves transfer energy from one place to another. No matter is transferred, so no solids, liquids or gases are transferred, it is only energy. Some waves must travel through a medium, such as sound waves and seismic waves. Sound waves travel through the air and seismic waves travel through the earth. Other waves do not need to travel through a medium and can travel through a vacuum, such as electromagnetic radiation. Here we have a diagram of a wave. We can work out the amplitude, wavelength and frequency of all waves. The amplitude is the disturbance from its undisturbed position. It is the distance between the rest point, which is the black center line or the x-axis, and the crest. It is important to make sure that we are not measuring the distance between the crest and the trough, as this will not work out the amplitude. So it's the difference between the crest and the black line, or the trough and the black line. On the diagram, this is shown by the distance y. We can also measure the wavelength. This is the length of a full cycle of the wave. It is the distance between the same point on a wave. It is easier to measure the wavelength using a trough or a crest, as during one wavelength the wave only crosses it once. If you use a rest point to measure the wavelength, you need to make sure that you allow the wave to cross the rest point twice. So if we look at the arrow that has just popped up that's measuring a wavelength from the rest point, we will see that the wave starts at the rest point, moves down to a trough, then comes back up, crosses the rest point, goes into a peak, and then comes back down to the rest point. So it crosses it twice, and that's how we measure a wavelength when we measure it from a rest point. Therefore, it's easier to measure a wavelength from a trough or a crest. The next thing we can measure is the frequency, and this can be measured in two ways. One way is to measure the total number of completed waves that pass through a certain point each second. The second way is to measure the number of waves being produced by a source each second. Frequency is measured in hertz, and 1 hertz is 1 wave per second. If a wave has a very high frequency, then we can measure it in kilohertz, megahertz or gigahertz. There are two types of waves, transverse waves and longitudinal waves. With transverse waves, the vibrations are perpendicular to the direction of the energy of the wave. Perpendicular means that they are at right angle to the direction of the energy of the waves. Here we have an arrow pointing to the right, indicating that the direction of energy is towards the right. With transverse waves, the waves will be going up and down if the energy is going to the right, and we can see this by the two greyish arrows that have popped up. Examples of transverse waves are electromagnetic waves and ripples on water. If we had a bucket of water and a little droplet fell into it, this would cause ripples on the water, and this is a transverse wave type. The next type of wave is longitudinal waves. These are vibrations that are parallel to the direction of the wave. Let's have an example of a stretched spring. If you push the spring, the waves will move along the spring in the same direction as the spring is facing. Sound waves, ultrasound and shock waves like seismic waves are an example of longitudinal waves. Here we have an arrow that is pointing rightwards. The wave energy is travelling in a rightwards direction. The wave vibrations would then be parallel to the direction of the waves, and this is indicated by the grey arrow that's just popped up. So with transverse waves, the vibrations are perpendicular to the direction of the energy of the wave, and with longitudinal waves, the waves are in the same direction as the direction of the energy of the wave. We can work out the speed of a wave by using the following formula. We use the formula V equals F times W. I've had to put W in because unfortunately Lambda doesn't work in this font. V is velocity or wave speed measured in meters per second. F is the frequency measured in hertz, and W, or lambda as it usually appears, is the wavelength, which is measured in meters. The speed of a wave is related to its frequency and wavelength. The higher both frequency and the wavelength is, the faster the wave will be travelling. So let's have an example. Suppose that we have a sound wave that has a frequency of 8,000 Hz and a wavelength of 0.041 meters. What is this wave's speed? We work the wave's speed out by using the formula above, which is V equals F times W, or lambda. V here is what we're trying to work out. F is given in the question, and this is 8,000 Hz. The wavelength is also given in the question, which is 0.041 meters. So to work out the wave speed, we do 8,000 Hz times 0.041 meters, which gives us a speed of 328 meters per second. So let's go through another example. We have a radio wave with a speed of 250 million meters per second and a wavelength of 90 meters. What is the frequency of this wave? In order to work this out, we need to slightly modify what our equation is. So initially we had our equation which was equal to V equals F times W, or lambda. So I've put the formula triangle here, which has V on the top and then F times W on the bottom. We want to work out what F is. In order to work out what we have to do when we want to find F, we cover F up on the formula diagram and see what is remaining and do that function. So if we cover F up, we see that we have to divide the velocity by the wavelength. So F is found by doing V divided by W. V is 250 million meters per second and the wavelength is 90. So we're doing 250 million divided by 90, which gives us a value of 2,777,777.78 Hz. We can put our answer into megahertz, and this gives us an answer of 2.78 megahertz. A megahertz is 1 million hertz, so we do our answer divided by a million, which gives us 2.782 decimal places. The final part of this video will be looking at frequency and time periods. A time period is the amount of time it takes for one complete oscillation, i.e. the amount of time that it takes for one wavelength to occur. If we know this, we can then work out what the frequency is by using the following formula. Frequency equals 1 over t, whereby F is frequency and t is time period. So let's have an example. It takes 0.000125 seconds for a sound wave oscillation. What is the frequency of this sound wave? To find the frequency of the sound wave, we have to do 1 divided by t, and t is given in the question. T is 0.000125. So to find the frequency, we do 1 divided by 0.000125, which gives us a frequency of 8,000 Hz, or 8 kilohertz. Have a go at the quiz on the website, which has lots of questions about wavelengths, wave speeds, and frequencies of waves. For more videos, content, quizzes, and past papers, go on to www.elevise.co.uk.